All right, this is another Riemann sum problem, but this time using a table of table of values instead of an actual graph. Again, the most important part of the Riemann sum procedure is really the x-axis. The y values will usually either be given to you like this, or it'll be on the graph or in a function where you just have to plug it in. Everything else is pretty much the same in terms of setting it up. Excuse me. Okay, so the table above gives the values of the function obtained from an experiment. Use them to estimate from 0 to 6 using three equal subintervals, and that's another keyword of saying use three rectangles, one with a right endpoint, left endpoint, and midpoints. Excuse me. And if the function is known to be a decreasing function, can you say whether your estimates are less than or greater than the exact value of the integral? So we'll talk about that at the end. Okay, so let's do the first one, the right endpoints here. Okay, so the key is again understanding how to set lay out your x-axis numbers. Okay, now some people they'll know what to do, so they'll just kind of like jump right in. But for us newbies, we need to take it step by step. So using three subintervals from 0 to 6, that means we want to create three big fat rectangles, right? So obviously it's got to be like this. It's got to be from here to here. Can you see that? Here, I'll just go like this from here to here, and then here to here, and here to here. Okay. All right. Now, technically, you can't plot the points, and you'll notice that you have a couple negative, which will go like down this way. Um, But I want to show you that you don't actually even have to see the graph. As long as you know how to work with the x values and you have the respective y values, you can just kind of like jump in. So if I want to use my right endpoints, my right part of the rectangle has to hit 2, and the y value has to be at 2 comma 8.3. So I'm gonna draw like this right now, okay? And I'll put a little dot here, and I'm gonna just draw some random rectangles. I'm not gonna even care about the shape or the size. Okay, see it? So there's three rectangles, and I've put the corner a designation on the upper right corner. So to find the area of this rectangle, which is area 1, it's basically width, which is 2 times the height. The height at x equals 2 is 8.3. So 8.3 is like that. So it's going to be 2 times 8.3. That's area 1. Area 2, which is over here, it's again going to be 2 times the height, but at 4. So it's going to be 2. And make sure you don't accidentally put the 4, which is an x value, over here. Here, we want the y value. So what's the height at 4? So go to 4, and we're at 2.3. So we're going to put here 2.3. So again, these are just area of rectangle numbers. And the third is basically 2 times the y value at 6. But notice that the y value 6 is negative 10.5. So this is going to be like 2 times negative 10.5. Now imagine, again, like you had a graph and you had no idea if the graph went up above the x-axis or even below. Again, if you just kind of drew this out, you'll know that you'll plug in 6 into that function, and if it turns out it's a negative, you can just, redraw this as like going like this. Okay? You see what I'm saying? Like you're only concerned about the width and the height of that rectangle. Okay, so area 1, let's use our calculator. You just have to add these up. So 8.3 times 2, uh, that's basically 16.6. Here, I'll just do it as an area total. 2 times 2.3, that's 4.6. And negative 10.5 times 2, which is negative 21. Okay, so just add those up together. 16.6 plus 4.6 minus 21, and we get 0. What? 2. Now, obviously, this estimation is really off, but it's just, again, an estimation of the area underneath the curve. Okay, what about on the center? So I just repasted this, we're going to use the same numbers again. I'm sorry, not the center, but we're going to use the left endpoints. Now, again, when you get good at this, you realize, oh, the left endpoint is going to start here. You see that? Excuse me. So the rectangle here will be like this. You see it? Wait, no. The width has to be bigger. So it's going to be like that. And then another one like this, but right here. This one which should be right here, but this should go, you know, down to negative 7.6. But just for the sake of knowing which numbers to use, now I'm going to use this notation. Some of you might be familiar with this, but I'm going to go like this. The area total is basically the width, which is delta x, times the height. Okay, all the height, the sum of all the heights. Okay, so delta x is going to be 2, right? So I'll just put 2 here times, and I'm going to put right here f at 0 plus f at, the second number here will be at, let's see, what would it be? At, oh, it's going to be like this. Um, yeah, so this would be, so this would be 0, 1, 2, 3, 4, 5, 6. So it'll be like this, this, this. So at x equals 2. Um, so it'll be f at 2, and then f at what? F at 4, okay? All right, and then you'll just multiply this out, or just figure out the y value. So the first one is at 9.3. F at 2 will be at 8.3. And then f at 4 will be at 2.3, okay? All right, and here we get all positive numbers. Okay, so let's multiply that out to parentheses 9.3 plus 8.3 plus 2.3. We get 39.8, which is the right answer. Okay. Oh my goodness, I don't know why I'm hiccuping so much. One time I hiccuped for 4 days straight, and I couldn't stop, and it was the most miserable time of my life. Okay, now here we're going to use the center. So if the width of the rectangle starts at 0, 1, 2, and it's going to be like this, we're going to use this portion right over here, okay, for our height. So that means it's going to be at 1, 3, it's going to be at 1, it's going to be at 3, and it's going to be at what? And 5. Does that make sense? If you're following, it should start making sense. So again, area total, just to kind of speed this up. Delta x, which is 2, times f at 1 plus f at 3 plus f at what? F at 5. So it'll be 2 times 9.0 plus 6.5 plus, or negative, or minus 7.6. Okay, so 2 parentheses 9 plus 6.5 minus 7.6, close parentheses, and enter. We got 15.8 units. Okay. Okay, now they're asking us conceptual problem. It says here, if the function is known to be decreasing, what does that mean? Well, in calculus terms, a decreasing function means that the slope is negative. So basically, it's going to go something like that, okay? So what they're saying is, since it's that way, can you say whether your estimates are greater or less than the exact value of the integral? Well, for each, we got to look at each one separately. So if you look at the first one, here, let me do this. Let me actually just plot out the coordinates here. So we got 0, 9.3, 1, 9.0, 2, 8.3, 3, 6.5, 4, it's getting smaller and smaller, and then we got 5, you get negative, and 6, you get even more what? excuse me, more negative. So again, the curve will look something like that. So when it's decreasing and you use a right endpoint for our first one that we did here, you'll notice that you'll end up getting a graph or a bunch of, oops, wait, we want three subintervals, right? So we got to do it from here. See this? Yeah. And you'll notice that because if it's decreasing, if it's in the right corner, you're going to have all this space what open. So we're going to get an under approximation. But when you use um, the left corner, notice how it sticks out. See that? You can get an over what approximation. When you use the center, you get part under and part over. Okay. So oops, it will be like so part under and part over approximation, and obviously this one down here will get over and under, but it's in the negatives. Okay. Oops, I didn't draw that right. Okay, like that. Okay, so I think that helps. I hope that helps. I'll see you in the next video.